changing the bounds once again. We talked about last time there are 6 different ways to do these triple integrals. It doesn't actually matter which way you do it. Most of the time you just choose whichever way is easiest. Which means sometimes when you set up an integral or are given an integral, we're going to want to swap the bounds out to make it easier to actually integrate. And so what we're going to do today is we're going to start with an example. We're going to look at changing the bounds. The example we're going to be looking at is integral from 0 to 1, 0 to x squared, 0 to y, f, x, y, z, dz, dy, dx. And what we want to do is we want to reorder this integral. So reorder. Integration. So that we do x first. Lines up. Y. Then z. What we want to do here is we want to reorder it so we're integrating just with respect to a different variable first. When we go to reorder the integration, once again, the main strategy behind this, the main reason why we want to do it is so that whatever this function is can be integrated easier. We ran into this with double integrals too. Sometimes you can't integrate it with respect to one variable. You've got to swap it around to do it with respect to the other. If we're going to reorder the integration, the first thing we need to do is look at the bounds we have. That's the only hint we have here, right? We don't actually know anything about our function. We don't need to. We don't look at the function when we're talking about the domain. So we're going to look at the bounds first. What I'm going to do is I'm going to write each of them out. I know that x is bordered between 1 and 0. Everyone's okay with that? I know y is bordered between what? 0 and x squared, right? And finally, I know z is bordered between 0 and y. This is what I'm given. What I'm going to do now is I'm going to take each of these, I'm going to draw them out in the respective plane. That is, let's look at this one first. What I'm going to do is I'm going to look at the y, z plane, and I'm going to draw what that actually looks like. Now I know z is bounded below by 0, right? And it goes up to y. So what I'm going to end up with here is the line y equals z. Everyone's okay with that, right? For my upper bound. And my lower bound is 0. And so what I end up with is some weird things shaded down below here. Now at this point, I don't have a cutoff on the right-hand side, right? And I really don't even know about this over here, except for the idea that z is bounded by 0. I'm going to do the same thing for the xy plane. I know that y is bounded below by 0 and above by x squared. So what I'm going to do is I'm going to draw an x squared here. I'm trying to curve all the way up. There we go. Much better. And so I know this is bounded once again below by 0, so I'm going to shade it over here. Now noticing I'm only drawing the positive side. At this point, I actually don't know if it's the positive or the negative. I'm just being kind of lazy about it. There's one other plane I need to draw here. What else do I need to draw? Right? Nope. Nope. Just a second. Oh, yeah, I can actually answer that. You're not where I thought you were. Yeah, I don't know if it's down below, because it could be bounded here by 0. So what I need to think about here, and there's a couple ways to tell this, is the one I'm missing, which is what? Missing x and z. Now, do I have a relationship between x and z as is? No, but I know something about x, right? What do I know about x? It's 0 to 1. And so suddenly I know x is bounded between here and here. And if x is bounded between there, what about over here? Still got to have those bounds, right? Which means x is bounded between here and here, which means suddenly I have that cutoff right there. And that's because x is bounded between 0 and 1. Now if x is bounded between 0 and 1, what is this cutoff point for y here? I plug it in. Where am I plugging it into? I'm plugging into this function, which is y equals x squared, right? So it's going to be at 1, which means I can come back here and what is this one bounded at? 0 and 1. Because this is the line y equals z. So if y is equal to 1, z can only be equal to 1 as well. And so what I've done here is I've drawn out all three of these. Now I don't really have anything on that far side. What I want to do is go ahead and graph this one somehow. I want a relationship between x and z. Well, we gotta think about this a little bit, right? Let's leave it as is and talk about how I'm going to reorder this. I want to integrate with respect to x first, right? So I'm going to put a dx on the inside. Good my integral. What was the next variable I wanted to integrate with respect to? Y, right? So I'll have some integral with respect to y, and then z. Some integral with respect to z. The easiest thing to do here is start on the outside and work in. That is, I know I should have constant values, scalar values on the outside, right? My last integral shouldn't have functions in it. So if I'm doing z last, what are my bounds for z? I'm here 0 to 1, right? I can see that from this drawing I have here. If y goes up to 1, z can only go up to 1 as well. Everyone's okay with that? Okay, now I need the bounds for y. These bounds for y, could they include an x in it? That is, could I have something like x squared there? Would that be okay?
No.
Why not?
You've already integrated x.
I've already integrated with respect to x, right? Which means that whatever I have here can only either be a scalar or a z value. We need to think about this here. What relationship do we have? Well, I know y starts at what? What's my lower bound for y? 0. And what does it go up to?
1.
It goes up to z. You guys are excellent this morning. That's exactly right. And I can tell that because I'm running y over here, right? From 0 up to that equation of y equals z. Okay. Final one. I need to talk about x. Well, where does x start? 0. Now, just a second. Do I have a relationship between x and z that's easy to see? No, right? That's why I have this huge blank thing on this graph over here. I'm not really sure. I do have a relationship between x and y, though, right? I have that y equals x squared. Well, if I have y equals x squared, this bound needs to be in terms of y, right? Because I'm integrating with respect to x. So if x is equal, sorry, if y is equal to x squared, I would have x equals square root of 1. How come I can write that like that? Normally when you square root, what do you have to put in front? What's the matter? Why can I just write it like this? I'm only on the positive side. How do I know I'm only on the positive side? Alright. I know I'm only looking at x from 0 to 1. I'm only looking at the positive side. Now, this probably seems kind of dumb. You just wasted a whole bunch of time. The reason why we would want to do something like this, I'm going to write in my function really quick, is because the function on the inside might be easier to integrate with respect to x than with respect to z. Main reason why we want to do it. Easier to switch the bounds if the integral can't be solved as is. Question?
So the first column from this one, from 0 to z.
I can't do 0 to z from here. From here?
Yeah, I understand. So how do you count the zero?
Well, this is with respect to z, so I could never have a z in the actual integral. The outside integral should always involve scalars or constant values. I know this because I know x was between 0 and 1. If x is between 0 and 1, y is between 0 and 1 because of this. And if y is between 0 and 1, z has to be between 0 and 1 because of that. So I work backwards with my function. Yeah.
Is this identical to 0 to 1 instead of y to 1?
Z to 1?
Because the bottom function is 3 and a half.
Let me look at it just a second. I wasn't paying a heck of a lot of attention. So you're saying this one, you're asking me should it be z to 1? Yes. Is that right? Let's see, which one did this come off of here? This one came off of this, right? And so we're integrating with respect to y. Awesome. Okay, catch Hannah. So,
Five's on the bottom.
okay. Let's think about this here. This bound is for y, right? So I need to think about, if I'm running y along the horizontal axis here, which one's further away? And Hannah's exactly right. If you look at this, my upper bound for y is 1, right? And the lower one is that line y equals z. You are exactly right. Very good catch. Very good catch. Awesome. I don't want to confuse you. Do you understand what Hannah was asking? Do you understand why that's the way we're doing it? Exactly. Mm-hmm. Yeah, it's kind of like that head 2 we did with double intervals. The third one's messed up too. And then now you're going to be the death of me. Okay, let's look at the third one. dx. We're looking at, wait, which one do you mean by the third one before I do this?
The one in
This one here, so the first one.
Oh, okay.
Okay. First or third, how many times you look at it? Let's look at that one for dx. So if we look at this one over here, it's gonna be just kind of morning, I can tell already. Okay, so we're doing it with x, right? Which one's my upper value?
No, R is 1.
Everyone in this room is doing exactly what I did when I looked at it for 30 seconds. That is, you're thinking upper being top, right? But we need to think about what variable we're running here. We're running x, right? So when we look at this, when we talk top with x, we're talking which one is the greatest distance away from here, right? The greatest distance away from x equals 0, which would be what? 1. And bottom one, square root y. Like 30 seconds. Okay, we should probably check the first one, right? Okay, there's no way to screw that one up. Okay. Are there questions about this? I'm very glad you caught that. I'm really glad you said something too. How long were you sitting on it? Before you said it? Gotta be quicker. You gotta tell me as soon as it goes up wrong. Okay. Question. Here's what is a really important point in any of your classes. If someone writes down something and you think it's wrong, and you look at it for like 10 seconds and you still think it's wrong, don't be afraid to say something. Like, I'm gonna make a mistake. You already know that. I gotta do fractions. That was kind of big. Question. Quicker. We actually don't have time to do another one somewhere. The bounds thing, you're gonna do one of them on your homework. The bounds, swapping them aren't an enormous